Looking at this SR-71 Blackbird, you see exactly how Lockheed Martin's Skunk Works division built a global reputation for delivering advanced classified aircraft. They'd followed it up with the F-117 Nighthawk, cementing a high-stakes aviation legacy that defined their engineering shop for decades. Then they made a sharp, unexpected pivot. A historically secretive aerospace facility suddenly directed its focus toward global energy generation. The story went public on February 7, 2013, when Charles Chase stepped onto Google's Solve for X stage in Half Moon Bay to outline Lockheed's new vision. He'd made a very specific promise on their behalf. They deliver a working 100 megawatt prototype within 5 years and a fully engineered power plant within 10. Setting a bold timeline like that immediately shifted global expectations for fusion energy. A major defense contractor going on the record about an energy breakthrough carries significant weight. A year and a half later, on October 15, 2014, Skunk Works held a public reveal during a facility tour. Aviation Week broke the technical details in a piece published that exact same day. The project officially received its public name. They called it the Compact Fusion Reactor, or CFR. This announcement came directly from Lockheed's Advanced Development Programs division. It carried the full institutional weight of a top-tier defense contractor, rather than a venture-backed startup. Staking their reputation on an energy breakthrough naturally drew enormous media attention, but it quickly invited immediate and intense scientific pushback. The CFR relied on a specific physics approach known as a field-reversed configuration. This animated diagram illustrates how it works. A field-reversed configuration's a compact spheroidal geometry, where the plasma creates its own confining magnetic field, folding in on itself to form a self-confining plasma toroid. They targeted a critical metric called beta. Beta is the ratio of plasma pressure to magnetic pressure, and Lockheed claimed they'd achieve a beta of approximately 1.0. Standard tokamaks typically hit a beta of around 0.05. Hitting 1.0 theoretically means a much more efficient use of the magnetic field, which enables a vastly smaller reactor. Thomas McGuire led the design for the T4B prototype, serving as the named inventor on the project's public patents. This schematic overlay shows the 3 key public filings that established their theoretical basis. McGuire's name sits on U.S. patents 9947420, 99959 and the 2018 application ending in 47462. Those filings describe the theory perfectly, but the gap between theoretical patent designs and proven laboratory performance didn't close in the public literature. The CFR program hasn't published any peer-reviewed performance data. Looking at the Great Dome at MIT, you see the institutional physics community that pushed back. Researchers there, along with the Cullum Center in the UK, didn't buy the claims, and Nature published a 2014 piece outlining the severe mainstream scientific skepticism. The core scientific objection was highly technical. Field-reversed configuration plasmas face severe instability problems at fusion-relevant temperatures, and you can't simply hand-wave those physics constraints. By 2017, leaked reports indicated the T4B prototype wasn't fully functional. They'd built a testing prototype called the TX, but it ultimately weighed roughly 2,000 tons. The engineering reality of immense scale and uncontrollable plasma directly contradicted their original promises of a compact truck-portable device. We jump forward to August 28, 2023, when a Lockheed Martin executive confirmed the program's end to Steve Trimble at Aviation Week. The executive stated they were no longer pursuing the Compact Fusion Reactor, confirming the actual cancellation occurred at least 3 years prior, by August 2020. This split-screen layout highlights a sharp contradiction. On one side's Lockheed's quiet corporate cancellation, and on the other is text from Charles Chase's own UnLAB resume. Chase specifically wrote that the CFR was breathing on its own, adding that the experimental campaign was very successful to date. A complete corporate shutdown doesn't align with the chief architect publicly claiming experimental success. A program described internally as successful ended without producing any published technical postmortem. We're left with 3 possibilities. They hit severe plasma instability barriers, the original announcement was premature, or the program went classified. This image of the Malaysia Airlines Boeing 777 ties into an argument from Forbes, which connects the CFR's field-reversed configuration geometry to the orb signatures seen in the MH370 footage. The Four Orbs assessment rates that connection as highly speculative, leaving the CFR as a documented engineering mystery, where the lack of evidence is as striking as the original promises.